All right, today we're going to pull back the curtain on the language of psychology. I'm talking about the stats, the numbers that are really the foundation of pretty much all research. We're going to figure out how psychologists actually know what they say they know.
You've seen the headlines, right? New therapy is a game changer, or this one simple habit will make you happier. But what does that really mean? How in the world do researchers talk to, say, 100 people and then make these huge claims about everyone? Well, that's exactly what we're going to break down. So why should you even care about this stuff? Look, understanding this is like getting a backstage pass to the entire field of psychology. It's the key that lets you go beyond the headlines to really get what the research is saying. It sharpens your critical thinking skills and helps you move from just having a gut feeling to actually understanding the evidence.
Okay, so every single researcher in psychology runs into the exact same massive challenge. You just can't study everyone. It's impossible, right? And that creates this fundamental tension, this gap between the whole group we want to know about and the small piece we can actually get our hands on to study.
So let's start with the big picture. That's what we call the population. This is the entire group of researchers interested in. Think big, like all high school students in America, or every adult dealing with anxiety. It's the everyone that the study is ultimately about.
Now, obviously, you can't survey every single high school student in the country. It's just not going to happen. So what do? You take a sample. A sample is just a smaller, manageable slice of that bigger population. And the whole goal, the dream really, is that this small group will be a good representation of the whole.
I know, population and sample can sound a little academic, a little abstract. So let's make this super simple. The best way to think about this is with a giant pot of soup.
Okay, picture it. The entire massive pot of soup, that's your population. The true overall flavor of that entire pot, if you could somehow taste it all at once, that's called the parameter. Now, you're not going to drink the whole pot, right? So you take a spoonful to taste it. That spoonful, that's your sample. And the specific flavor of your little spoonful, that is your statistic. See how that works? Use the statistic from the sample to guess what the parameter of the population is like.
But here's the catch, and it's a big one. What if your spoonful just happens to have an extra piece of carrot? Or maybe it missed the salty part? That tiny, natural difference between what's in your sample spoonful and what's in the population pot is called sampling error. And this is crucial. It's not a mistake. Nobody messed up. It's just a natural, expected variation that researchers always have to think about.
All right, you ready for a quick pop quiz? Let's see if you've got it. A researcher is studying how sleep affects exam scores, and they gather data from 75 high school boys. In that study, what are those 75 boys? Are they A, a population, B, a parameter, or C, a sample? Think about it for a second.
And the answer is C, a sample. Yes. If you got that, you're spot on. The researcher isn't only interested in those 75 boys. They're interested in all high school boys. So the 75 they're actually studying are just the sample. Awesome.
So, okay, the researcher has their sample. They've collected their data. Now what? What do they actually do with all those numbers? Well, this is where statistics comes in, and it really has two main jobs: describing what you found and then trying to generalize from it. And this breaks down into two big categories. On one hand, you have descriptive statistics. This is pretty straightforward. It's just describing the data you have, summarizing it, organizing it, making it simple, like calculating the average test score for those 75 boys in your sample. But then you have inferential statistics. And this is where the magic happens. This is the big leap, where you use the data from your small sample to make an educated guess, an inference, about the entire population.
Okay, so we're clear on studying samples to learn about populations. But what are we actually measuring? What is this data we keep talking about? Well, that brings us down to the fundamental building blocks, things called variables, and the scales we use to measure them.
So, the most basic idea here is a variable. It sounds fancy, but it's really simple. A variable is just anything that can change or vary. In psychology, variables are everywhere. Stress levels can go up or down. IQ scores are different from person to person. Mood changes. The number of times you go to therapy, that can change. If it can have different values, guess what? It's a variable.
And these variables basically come in two main flavors. First, you've got discrete variables. These are things you can count in whole numbers, like the number of siblings you have. You can have 2 siblings or 3, but you can't have 2.5 siblings, right?
On the other hand, you have continuous variables. These are things you measure, like your height or weight, or even a self-esteem score on a survey. There are basically an infinite number of possible values between any 2 points.
So, if we're measuring all these different variables, what kind of ruler are we even using? Because you can't measure happiness the same way you measure height. Turns out, psychologists have 4 main types of measurement scales, and each one has its own set of rules.
Let's do a quick rundown. First up is nominal. Think names. It just puts things in categories, like anxiety or depression. Then there's ordinal, which puts those categories in an order. Think dissatisfied, neutral, satisfied. Next is interval, which has an order and equal intervals between the points, like temperature or an IQ score. But the key here is there's no true zero. And finally, you have ratio. It's just like an interval scale, but it does have a true absolute zero, like the number of stressful events in a week. You can absolutely have 0 of those.
Okay, but this is where it gets really interesting. You'd think these rules are set in stone, but there's a bit of a gray area. This quote here points out something fascinating. A lot of what we measure in psychology, things like personality or intelligence, are strictly speaking ordinal. We can rank them, but are the distances between the points truly equal? Probably not. But most researchers go ahead and treat them as interval data anyway, because it lets them do much more powerful statistical tests. It's a practical compromise, and it's a really important one to know about.
And that brings us to our final big question. Think about it. We're using a tiny sample spoonful to guess the flavor of a whole pot. And we know there's always going to be some sampling error. And on top of that, the rulers we're using to measure things aren't always a perfect fit for what we're studying. So if that's the case, what does that really tell us about how certain we can be about psychological research? Well, it tells us it's a science built on careful estimates, on powerful insights drawn from imperfect data, and not a never-ending quest to find better, more accurate tools.